Hello, this is Adam from Pinhead's Pinball, and I have a Data East version 3 CPU board on the bench right now, and I would just like to show you an overview of how to use the Leon test ROMs. Now, it's the same test ROM for System 11 boards and this version of the Data East CPU board, and what it does is it sends code to all the PIA chips. And in this case, we have 1, 2, 3, 4, 5, 6. They run all your coils, switch matrix, lamp matrix, sound, and display data. So ultimately, this can help you restore a board that doesn't boot at all. If you've got some issues with some solenoid channels and you haven't really been able to be successful in tracing down the logic, that's causing those problems, it can also be really helpful. This happens to be, as far as I know, a fully functional board, so I'm just going to show you how you can use it to test the outputs of the PIAs. Okay, so we've got our board here. I've already plugged it into ground on the left and 5 volts on the right. There's 2 test pins up here. I've also got my logic probe plugged in, so you'll see a little extra clutter up there. And some people prefer to use the logic probes. Other people like to put testers on the actual header pins. The logic probes you can touch anywhere. You can touch the header pins. You can touch transistors, the base of the transistors. You can touch each individual logic chip, input and output, to try to really work backwards or forwards to finding where your problem is. It's a great way to troubleshoot, especially coil drive issues. Either your standard 1 through 16 coils or your special solenoids up here. These illuminated testers, these are from Siegecraft. These are great. They don't show up great on the video because the flicker is very quick. So I'm not going to spend much time on those, but you can populate them in the solenoid. You can watch the switch matrix drive header. You can watch most of the output pins on the special solenoid. You can also watch the lamp matrix. You just have to do some other stuff to make that work, which Leon describes in his documentation. So let's get to it. We're going to pull out the game ROM that happens to be installed in CPU slot 5C. So Data East, Atari did this too. They've got columns, numbered columns, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then they have lettered rows, A, B, C, D, E, F, G, H, I, J. I think that's as far as they go. So I don't know much about the naming convention. For example, this chip spans 2 columns, but apparently it's 5 Charlie. So Leon tells us that that's the ROM that we're supposed to pull out. So we'll pull out that game ROM, and we'll put in our test ROM. And Data East blessed us with the opportunity to have silk screening on the board right side up, or the chip silk screening right side up. You can choose. I prefer to have the board silk screening right side up when I'm working on a chip, but you always got to remember that that means your pin 1, instead of being on the bottom left, is now the top right. So putting the chip in upside down, which happens to be right side up. Maybe there's a reason they did that. I don't know. Drives me nuts. Okay, so test ROM's in. So all this test ROM's going to do is drive the outputs of the PIA, all the PIAs on and off. And each PIA has 2 banks of outputs with 8 each, so a total of 16 outputs. So we'll power up the board here. Okay, so we can see, looking at these LEDs, that we've got 5 volts, the board powered on, it loaded the code, it's running the code because we see what we should be seeing here. Now the CPU chip might still be running the code if you don't see these flashing. You're going to see the 5 volt LED unless there's an issue with your board that with the 5 volt indicator circuit. But just because you don't see these flashing doesn't mean the code's not running. You should see those flashing, and you should be able to hear or feel the flipper relay toggle on and off also. if the PIA that drives these three indicators, right, the blanking LED, PIA LED, and the flipper relay, if that's not working, you won't see those. So we can check to make sure the code's running by grabbing our logic probe, which is hooked up to 5 volts and ground, and marching over to pin 15 on the CPU. So 1, 2, 3, 4, 5, 6, 7, 8, 12, 13, 14. Okay, so we're getting a toggle signal there, so we know that the code is running properly. Okay, so now we just march around all the PIAs. We'll start here with IC5F, and the PIA outputs are between pins 2 and 17, 16 of them. So this is an indication that that PIA pin is doing what it's supposed to. So just march through. Pin 17. So those are all good. Let's go over to 7 Bravo. Okay, those are all fine. Now we'll pop down to 8 here. Okay, so this is driving the switch matrix. And in order to make this test work, you have to ground all the pins at connector CN10, which Leon talks about. This is all straight from Leon's documentation that came with his ROMs. I have done that by weaving bus wire around the header pins and then twisting it to the ground test point. You could come up with a more elegant solution. You could take a 9-pin connector and short all the wires, tie all the wires together, and put a test clip on that and go to ground. That'd be great. I didn't feel like doing that, so I just have all this bus wire twisted around all the header pins. So if you don't do that, you're not going to be able to read these first set of pins. So we'll start with pin 2. Okay, so those are all good. Now let's pop up to 9 Bravo, and then we've got 11 Bravo, and then 11 Echo. And those are our last 3 PIAs to check. And there's something fun with this one, but we'll start here. Good. Now, on 11B, 11 Bravo, pin 9 is grounded. So we're not going to see any toggle on pin 9. So we got 2, 3, 4, 5, 6, 7, 8, 9. It's just going to be low. That's just what it is. It's a not grounded output. Okay, and then on to our last one, 11 Echo. Okay, so all the PIA outputs are good. It doesn't mean all the logic chips are good downstream of that, or transistors, there's not a short somewhere, but the outputs of the PIAs are all solid. So we don't have to worry about replacing any of those PIAs, which you would involve desoldering the PIA, installing a socket and a new PIA, or you can just cut the legs of the PIA chip itself and remove the body and then heat and pull each of the pins. Okay, so I'm also going to show you quickly how you might do a visual test of this. So I'm going to ramp the power supply for the second channel down to 5 volts. And power one of these guys up. Okay. So the frame rate, hopefully you can see that. It's a very quick flicker. Okay, so I'm just using these Siegecraft testers, and when a pin is connected to ground through the transistor that's hooked up to that header pin, it completes the circuit, and we just have a 5-volt supply going into the LED, and there's a current limiting resistor pack on the LED. So it's very simple, and this works on all the solenoid drive channels, on switch matrix, and then also you can see it on the lamp matrix, but you have to follow Leon's specific directions on how to watch the lamp matrix visually. And you can also create your own LED testers for the smaller set of header pins for the ribbon cables. Okay, so that's how that works, and you certainly can also take your logic probe and go straight to the end of the signal chain. So for example, switch matrix. On these drives you can just test right at the header pin, and you're going to see the same dancing signal, as Leon calls it, this toggle between high and low. So here's where you can start there and work backwards through the transistors, through the logic, all the way back to the PIA. Same thing with the solenoid, drive, lamp matrix, everything. Incredibly helpful. It is the only way that you can really figure out what's going on with these boards in an efficient fashion, in my opinion. So I hope that's been somewhat interesting, and enjoy working on pinball, and stay safe. Okay, so to test the lamp matrix section, you test the drive connector CN7 just as you would the others. So we'll go ahead and apply 5 volts to this tester, and we're getting 4 flashes, a key, and 4 flashes. Okay, so that's what we expect. So that's working properly. Now, to test the returns, we have to do it just a little differently. We're missing the 18 volts that's used to drive the switch matrix. So when we're testing the returns, we need to add a voltage. In this case, we can just use 5 volts here to CN4. All these pins are bused together. So I'm just going to grab pin 9 to drive my solenoid tester. Now this one's nice and bright. You should be able to see this on the video. We got 3 on, 1 off for the key, and then 5 on, which you'll hear and see with the logic probe. Just float at the key high. There we go. So everything's working good. So that lamp matrix is working as expected. No issues found.